Have you ever wondered if you could create your own GPS security system without paying for expensive subscriptions? Imagine your child is playing in a park, your bike parked outside your home, your pet running around the garden, or even valuable equipment kept on a construction site. What if the moment they leave a safe zone, you receiving an instant warning? Well, that's exactly what I have built. In today's project, I will show you how an ESP8266 and NEO-7M GPS module can create a live GPS. In today's video, I will show you how an ESP8266 and a NEO-7M GPS module can create a live GPS geofencing system. You will be able to monitor the location directly from your phone, draw a circular or irregular safety zone, and the moment the GPS moves outside the area, the buzzer immediately turns on. But that's not all. The system also tells you how far the GPS has moved away from the safe zone. And the best part, you don't need any paid service or mobile application. Everything works directly through your phone using the ESP8266 IP address. So let's see how it works. Hello everyone, welcome back to the InfoFlux. If you are interested in Arduino, ESP8266, ESP32, IoT, robotics, GPS tracking or smart electronic project, you are in the right place. In my previous video, we have built a live GPS tracker where the latitude and longitude were displayed on a mobile phone using the ESP8266. That project allowed us to monitor the GPS position in real time. But today, we are taking this project to the next level by adding one of the most useful GPS features used in professional tracking system, geofencing. So what is geofencing? A geofence is a simple virtual boundary that you defined on a map. As long as the GPS remains inside this boundary, everything is normal. The moment it crosses the boundary, the system detects it instantly and performs an action. In this project, that action is activating buzzer to alert you immediately. To make the system even more powerful, I have added two different types of geofences. The first circular geofence, which is ideal for parks, homes, parking system, playgrounds, warehouse or even open fields. The second is irregular polygon geofence, allowing you to create custom shaped boundaries that match almost any real location. This is especially usually when a circular boundary would include unnecessary areas or fail to match the actual shape of the location. You can choose either mode directly from your phone. If you want a different boundary, simply clear the existing one and draw a new one in seconds. The entire process is simple, fast and runs locally using the ESP8266. No dedicated mobile application, no monthly subscription, no paid cloud platform. Just connect your phone ESP8266, open its IP address in your browser and you are ready to use this system. So without wasting any time, let's get started. Before we test the project, let's quickly take a look at the hardware used to build this GPS geofencing system. At the heart of this system is the ESP8266, which acts as a brain of the system. It reads the GPS data, creates the local web server, calculates the geofence status, and controls the buzzer. Next, we have the NEO-7M GPS module, which continuously receives satellite signals and provides accurate latitude and longitude coordinates. To display important information directly on the device, I am using a 0.96-inch SSD1306 OLED display. It shows the GPS coordinates, geofence status and the distance from the safe zone, so you don't always need to look at your phone. For alerts, I have connected a buzzer module. Whenever the GPS crosses the defined boundary, the buzzer immediately turns on. Once the GPS returns inside the safe zone, it automatically turns off. Everything is assembled on a breadboard using a jumper wires. making the project simple to build and easy to modify. Although the hardware is straightforward, the features it provides are similar to those found in commercial GPS tracking system. Before connecting the module, let's have a closer look at the new 7M GPS module. On the front side of the module, the most noticeable component is the white square ceramic GPS antenna. This ceramic antenna is responsible for receiving signals from GPS satellites orbiting the Earth. The quality of the received signals directly affect how quickly and accurately the module can determine its location. On this side, we can also see the connection pins labeled VCC, ground, TX and RX. These pins are used for interface the GPS module with the Arduino. The VCC pin provides power to the module, ground is connected to ground, TX sends GPS data to the Arduino, and RX can receive serial commands if needed. On the back side, we can see the new 7N GPS chip, which is the main processor responsible for receiving and decoding satellite signals. Surrounding the chip are several resistors and capacitors that help with the signal filtering, voltage regulation and stable operation of the module. We can also see the PPS LED, which stands for Pulse Per Second LED. This LED provides a visual indication of GPS status. When the module starts receiving satellite signals and obtain a GPS fix, the LED begins blinking at regular intervals. Another useful feature visible on the backside is the USB interface. This interface allows the GPS module to be connected directly to a computer for configuration, testing and monitoring using GPS software without requiring a microcontroller. Overall, the new 7M module is compact and powerful GPS solution that combines the ceramic antenna, new 7N GPS receiver chip, PPS status LED, USB interface and supporting electronic components on a single board. Now I am going to connect the GPS antenna to the new 7M GPS module. This antenna is very important part of the GPS system because it receives signal from the GPS satellites. Without connecting the antenna, the module may not be able to receive satellite signals properly, and as a result, we will not get valid location data such as latitude, longitude, altitude or time. Therefore, before testing the GPS module, make sure the antenna is connected securely so the module can acquire satellite signals and provide accurate GPS information. Let's wire everything up. For the GPS module, VCC to 3.3 volt, ground to ground, GPS TX to D6, GPS RX to D5. For the OLED display, which uses I2C, VCC to 3.3 volt, ground to ground, SDA to D2, SCL to D1. And for the buzzer, VCC to 3.3 volt or 5 volt depending on your module, ground to ground and the signal pin to D7. Now install the required libraries. Tiny GPS++, Adafruit GFX library, Adafruit SSD1306. This project has two files that need to sit in the same folder, the main sketch and a file called web page. Before uploading, don't forget to enter your Wi-Fi name and password near the top of the sketch. Once they're done, hit upload. It's time to test out the project. Let's power up the project. As soon as the ESP8266 starts, it initializes the GPS module and begins searching for satellite signal. Depending on your location and weather conditions, it may take a few moments to lock onto enough satellites. Once a GPS fix is obtained, the OLED starts displaying the live latitude and longitude values. At the same time, the ESP8266 launches its built-in web server, allowing us to monitor everything directly from a mobile phone. No mobile application is required. Simply connect your mobile phone to the same network and open the ESP8266 IP address in your browser. After entering the ESP8266 IP address, the web page loads instantly. Here you can already see the live location of the GPS module on the map. One of the best things about this project is that everything works directly through your browser. There is no Android application to install. As the GPS moves, the marker updates continuously on the map, allowing us to monitor its position in real time. Because the project uses the leaflet mapping library, the interface is lightweight, responsive, and very easy to use. Now let's create our first geofence. From the interface, I will select circle mode. Then I will simply draw a circle around the current GPS position. That's it. Our safe zone has now been created. As long as the GPS remains inside the circle boundary, everything is operating normally. No buzzer, no warning. The system continuously checks the GPS position in the background. If I want to change the safe area later, I don't need to restart the project. I can simply press the clear button, remove the existing geofence and draw a new one within seconds. You can adjust the size of the circle. This makes the project very flexible for different locations. Now comes the exciting part. I have already created a circular safe zone. Now I am moving away from it. And as you can see, I am out here in the fields. I have restarted the ESP8266, so while the GPS module is acquiring satellite signals, the buzzer remains off. The moment the GPS obtains a valid fix and determines the device is outside the geofence, the buzzer immediately turns on. At the same time, the system displays exactly how far I am from the defined safe zone, giving me both an instant alert and a clear indication of the distance from the boundary. If you use a circular geofence, it might include roads, neighboring buildings, or empty land that you don't actually want to monitor. That's where the second feature of this project becomes incredibly useful. Instead of limiting yourself to a circle, you can create your own custom shaped geofence that matched the exact area you want to protect. Let's see how it works. From the web interface, I simply select Polygon mode. Now I can tap on different locations on the map to create a custom boundary. Unlike a circle, I am not restricted by a fixed radius. I can add points whenever I need them. Once all the points are placed, I simply complete the shape. And that's it. My custom geofence is now active. Next, I move outside this custom boundary and restart the ESP8266. While the GPS module is acquiring satellite signal, the buzzer remains off. As soon as the GPS obtains a valid fix and confirms that the device is outside the polygon. As soon as the GPS obtains a valid fix and confirms that the device is outside the polygon, Geofence, the buzzer immediately turns on, clearly indicating that we have left that safe zone. That's exactly what makes a Geofence such a powerful technology. So that's how you can build a complete GPS geofencing system using an ESP8266 and a NEO-7M GPS module. If you enjoyed this project and learned something new, don't forget to hit the like button because it really helps the channel grow. If you are new here and love Arduino, ESP8266, ESP32, IoT, robotics, automation and electronic project, make sure to subscribe and turn the notification bell so you never miss any future tutorials. Thanks for watching and I will see you in the next project.